How does backpropagation train neural networks in AI? Have you ever wondered how artificial intelligence learns from data? One of the key methods behind this learning is called the backpropagation algorithm. Let's break it down and see how it trains neural networks effectively. The backpropagation algorithm is essential for training artificial neural networks. It adjusts the internal parameters, known as weights and biases, to minimize the difference between what the network predicts and the actual target output. This process involves two main phases: the forward pass and the backward pass. During the forward pass, input data enters the network through the input layer. It then travels through one or more hidden layers. Each neuron in these layers calculates a weighted sum of its inputs, adds a bias, and applies an activation function, such as rectified linear unit or sigmoid. This process continues until the network generates its final prediction. Once the forward pass is complete, we move to the backward pass. Here, the algorithm calculates the error, which is the difference between the predicted output and the actual target output. This error is often measured using a loss function like mean squared error or cross entropy. Next, backpropagation uses the chain rule from calculus to compute the gradient of this error with respect to each weight and bias in the network. These gradients show how much each parameter contributes to the error. With these gradients in hand, the algorithm updates the weights and biases to reduce the error. This is typically done using an optimization method called gradient descent. The update process is repeated over many iterations with multiple training examples. This repetition allows the network to learn patterns in the data and improve its accuracy over time. Backpropagation is vital for training deep learning models that power many artificial intelligence applications. This includes language models like Chat Generative Pre-trained Transformer, image generators like DALL-E and Midjourney, and productivity plugins that use neural networks to understand and generate content. By efficiently computing how to adjust the network's parameters, backpropagation enables these models to learn from vast amounts of data. This learning allows them to perform complex tasks such as natural language understanding and image synthesis. In essence, backpropagation trains neural networks by propagating the error backward through the network to calculate gradients. These gradients are then used to update the network's parameters, improving its predictions over time. This process is a key reason why machine learning models can accomplish tasks that were once challenging for computers.